Okay. Okay, we should be live, I think. Okay, looks like we're live. Yeah, sorry for the late start. I just came back from the gym, so yeah. I guess with like the 4 minutes, it doesn't really make much sense to like just kind of like go through news. So if anyone wants to like chat, hit me up with a question or something before we get started. Feel free to throw something in the chat, man. Let's see what else we got going here. Okay, hold up. Yo, hey Justin. Any hints? I think he's been on stream before actually. I mean it's not. I wouldn't say it's like big, but it's just like how do I describe it? It's I would say it's relevant. Um, you might know. I think he might have talked on the stream before, but yeah. Let's see if anyone remembers. So it's not like a how to describe it. It's not like some super crazy special like celebrity. So I'll at least tell you that much. So if if you're expecting someone super famous, then it's not gonna be that. But I think a lot of the content I think a lot of the questions that we're gonna talk about are definitely things that that a lot of people will experience at some point in their career. So I think it's like I think it's really important for like people to listen in on it. So that's kind of like why I guess I did a little bit of the clickbait, but I still think it's like really important for people to kind of listen in on the conversation. Okay. Let's see. I don't know. None of these articles look that interesting to me, actually. I mean, none of this really is interesting. Meta deepens in its investment in Python? Really? Okay. Let's see what happened here. Backbone of Meta Services. PyTorch is built on Python. Oh, so it's just Python supporting ML stuff. Okay. $300,000 scholarship to the Python Software Foundation. Interesting. Okay. I mean, I don't have any gripes about it, actually. I think this is perfectly reasonable. And if anyone wants like $200,000, it's a scholarship that's up for grabs. So, I mean, I'm not an ML guy, but I think the guy I'm bringing on is though. He might be. Hold up. Let me get something. I'll be right back. Okay, and we're back. Cool beans. Oh, Java 18. Hold up. This one's actually kind of relevant to me. JDK 18, the reference implementation of Java 18 is now generally available. We shipped build 36. Okay. It doesn't seem like this is a long-term support. I don't know. Nothing in here strikes out to me as like something very important. Vector API maybe. Anyway, let's bring my client on. Let's see what's up. Hello.
Oh.
Hey, what's up?
Good. How about you?
Hey, doing good, doing good. Yeah, catch me up on your practice. I realized I kind of missed your question on DP, but how's that gone?
Hard. That's the only thing. But anyways, from Saturday, I mean, like, I'll explain the point where it's being hard.
Yeah.
From Saturday until today, first thing I did was to, like, understand time and complexity, so to make sure I don't mess it up with this anymore, any recursive problems.
Yes.
Yeah, it was kind of more okay to me to visualize and to come with a very accurate measure of time and space complexity. I did actually a write-up about this.
Okay.
And then I reviewed all of my, actually not all, because I got like the idea of how to analyze time and space complexity problems. So the past problems I did, where I messed it up a lot with time and space complexity. So I reviewed them with also with the book explanation, right? So first I tried to do it by myself just to see if I was able, and then I checked my answer based on the book to see what I missed.
Okay.
Yeah, I did this for I guess 4 or 5 problems. So
okay,
to
that's fine.
The instinct,
Okay, so it doesn't sound like you did too much dynamic programming. It sounds more like you just redid old problems and then did runtime.
No, I did more dynamic programming. The thing was, it's taking me too much for dynamic programming, like to understand where to put the memoization,
Oh.
So basically, and I started Sunday. Sunday I started with dynamic programming Sunday afternoon.
Oh.
So yeah. And other thing I studied, like and you're right, just in advance, you're right about how the concatenation of lists in Python work. It's like it create a new object of list and copy all the elements, so it's not efficient. Anyways, and I started with dynamic programming. Like the recursive part is much okay for me because I've been like focusing on recursion, but like to understand where do I need to the memoization, like for the first one was very not intuitive to me for the knapsack problem, So if you look, I like created the pseudocode for the naive approach, but I was more focused to understand how they came with the more optimized, And for I guess only for one problem I did like very good in terms of go from the beginning to the end with the memoization stuff. But yeah, it's taken too much time because I had to draw like the entire recursion tree to see where are the repeated actions, operations that are happening, and what can I optimize upon this. I even took like pictures of my whiteboard just to see, like just for this part of drawing the tree, because it's not so good to draw like a very big recursive tree. Just for this first problem, so I get the.
Is this the one that you copy pasted to me?
I put the link.
M6
of the practice sheet M6.
Okay.
Yeah.
Got it. So I'm gonna look at M6. Oh, I need requesting access. Just change it.
Oh, I thought
Okay. Let me see the time complexity analysis write up actually. Okay. Okay. Yeah. So that's your check-in. I see this. Yeah, access for both of them needed.
Ooh. Okay, I will try this one, please. And yeah, I change only one thing and forget the other. And yeah, any person with the link, copy the link. Yeah, and now yeah, this is the third one.
I see.
Okay.
Okay, cool. I think it's a good chance to talk about like dynamic programming since I don't do a lot of that. But bottom line, dynamic programming is just recursion, but with reusing previous computer results. That's it. So that's really where you want to what's it called insert the memoization, right? So if you think about like the states, right? Let's say I have states A, B, C, D, E, right? And then I'm trying states A, B, A, B, C, A, B, D, A, B, E, A, B, F, and then B, C, D, B, C, E, B, C, F, et cetera, right? Where I can start pruning things is if I select A, B, C or C, B, A. I've already computed A, B, C, and C, B, A, and state C, B, A is the equivalent. That's where you have the memoization. And so from there, once you have the memoization, then what you do is you draw the tree, figure out what states you want to keep, which states you don't want to keep, and add on to. Because essentially, it's like a linear recursive formula, right? For the runtime, where you just reuse the previous state, slap something else on top of it that isn't like recursive, and just, it's a constant thing. And then you create the new relationship. So now that I've given you kind of like the abstract version of it, it's really just identifying what you want to keep in that state, what you don't want to keep. So let's talk about like the 0-1 knapsack problem as like a example, right? So, and I think this one is from grokking, not grokking that dynamic.
It's for grokking.
Yeah.
All of those are for grokking.
Okay, cool. So the 0-1 knapsack problem. Given the weight and profits of n, we're asked to put these items in a knapsack or with capacity C. The goal is to get the maximum profit out of the knapsack items. Each item can only be selected once as we don't have multiple quantities. Okay, so that already does that for us. So immediately what I'm thinking is like, it doesn't matter if we put apple orange first or orange apple, right? Because at the end of the day, the knapsack itself is going to have an apple and an orange.
Yeah.
Right. So the direct naive solution, and you might remember this, is that just try every single possible combination of apple, orange, banana, melon until that is less than the profit size, right?
Yeah, that was clear for me.
The good news is that we can put one after the other, and then we can actually stop once we hit over the weight, because there's none of these items are going to have negative weight, right?
Yeah.
So
I'm on the same page for this one. Yeah.
So that's fine. But wait, what happened to the rest of the? What's this problem statement here? I'm looking at. Given two integers represent n in profit. Oh, okay, I see. You're actually restating this more like coding terms. That's fine.
Oh, this is actually they do two problem statements. Yeah.
Okay.
Yeah. Like it's like presentation of the problem, then like the actual problem statement. They do this grokking exercise.
That's kind of interesting. Okay, that's fine. Because to me, like I was a little bit confused, but like now I get it. Now this was just saying the technical version of it. Is like given two integer arrays to represent the weight and profits of n items, we need to find a subset of these items, which blah blah blah. It's basically what I already said. And then just try every single possible combination of items where one item only exists, right? So, yeah. So you did this, So you should be able to code the naive solution very well. So okay, looks like you just copy pasted this. Fine. Yeah. So this tree basically just represents all the possible pathways, right? So
that was what I was doing.
Right. So in this case, it just means that hey, we're gonna iterate for every single item. Either we pick it or we don't, right?
Yeah. That was clear. Yeah.
Yeah. So far so good, right? You understand profit, you understand weight, okay, cool.
Yeah,
and then just
that was
report
totally
all the way.
clear for me.
Alright. Okay, so
the only thing was like the way to memoize, so it was not very clear. So I focused much of my time on this. Yeah.
So the reason why the memoization should not be that difficult, only because well, we're asking ourselves the same exact question that we've been asking ourselves this entire time, right? What is the inefficiency? The inefficiency is I've already calculated apple orange. So it doesn't matter if I started with orange apple. Right? It doesn't matter the order of the items. And yet what we're doing here is literally just going back over and over and over the items.
Yeah.
So that's where the memoization comes in. So I believe in the book that what they do is they actually mark this, I think, with a if we've already solved similar problems, which is yeah, right here. So
Yeah. So, but this thing, how, for example, this is a 2D matrix, right? Like a 2D array. How do you like, for example, for the first, just to mention, I watched a few videos, like just to understand, just one video, just to understand.
Yeah.
The memoization. And for the Fibonacci problem, for example, was pretty clear, you know. So you check the index. But for example, this is a 2D array. How did they came with this idea of, okay, I'm gonna use the index and the capacity to map, you know? For me, it was just a magic bullet.
I see. Yeah. So you're trying to look for that link. Okay. So the index represents which item we're looking at, right?
For sure.
And then the capacity just means how much capacity of the knapsack that I can handle, right? So in a more concrete version, it just means that if I am looking at orange, well then I want to know what the possible capacity I can fill up with the maximum capacity minus the weight of the orange, right? So in this case, I want to know the maximum profit that I can get with a knapsack capacity of 4 that doesn't have the orange. So in other words, let me do this. Maybe this is a little bit easier. So
okay.
Max, let's call this max profit with the orange, right? It's going to be equal to the max profit without the orange plus the orange, right? So what's the max profit without the orange? So the max profit without the orange is going to be equal to, well, the max profit I can get is, well, since I'm bound by my capacity, will just be the max capacity minus the weight of the orange, and then combine it with all the other elements before it, plus the plus the orange stuff, right? So then, in other words, this state can be represented. This state right here can just be represented by the index, and then the the capacity minus weight of orange.
Ooh.
Does that make sense?
Yeah, that makes sense. So, I never thought about this. Yeah.
Remember how I said it's just manipulating the states?
Yes. Yeah.
And you can see, like, this is a linear arrangement. So it's like, oh, okay, so how do I represent this state? How do I represent the state of, oh, I want to try every single possible combination, the maximum profit of the, of all the other shit before it. So I should say, in this case, index minus 1, because index would just be orange. So index minus 1, which represents, recursively, all the other shit that comes before it. And then on the constraint that we need to have this capacity here. Because in theory, let's say, for instance, oh, why is it capacity of minus weight orange? Why not just like minus weight orange minus 1 or minus, minus 2 or minus n, right? Why this? Well, in what's called intuitively, we understand that, well, we want to have as much space in the backpack as we possibly can, because if for some freak, it'll never be the case where capacity orange minus 1 is going to be greater than the whatever we find at capacity minus weight of orange. The reason why is like, well, let's consider like reasonably, if I have a backpack that can hold a weight of 10, then I must be able to at least hold a backpack that has a weight of 9. All the elements that goes in a backpack of weight of 9, I can put into a weight of 10. Does that make sense?
Yes.
So it's like we can only go one direction. So it's like, if I have a backpack that holds 9 items, or let's say like 9 pounds, then I know I can put all the stuff in there and put it into a backpack that can hold up to 10 pounds. So that's what lends itself to the relationship and the DP table. It's just knowing that, hey, we just have to rely on what's backwards, but we can never go backwards. If that kind of makes sense.
Yeah.
No.
Yeah. I had to think about this once. Oh. Yeah. I just like solving the other problems. I realized, okay, maybe that's something to do with the index and like the operation I'm doing. So, but I didn't arrived in this conclusion. Yeah.
Once you understand it's just all about manipulating states, it becomes so much easier. So in this case, let's see the profit 1, profit 2, right? So how does this work with what we're doing up here? Let me copy paste this and bring it down into the code so it's a little bit easier to understand side by side. So we already have the memoization, but the next part is really being able to understand this state, right? This is probably what is tripping you up. The memoization is fine, but then now it's like, okay, well, if I want to achieve this state, well, there's two things I can do. Remember what I said before about the, hey, we can never go backwards? It should be
I remember.
Yeah. So then it should be one of these. Capacity minus weight. So it's like this is just represents the possible max capacity minus weight of orange. So basically, you can think of this like without orange plus the orange itself. Right?
Okay, so you're looking to the states. Oh, okay.
Yep. And this one just means
states that changed.
Yeah. So and this one just means that, hey, what if we don't add the orange at all?
Yeah, for sure.
Yeah. So it's really what it's just like when you have this, it's like understanding the decision tree. Remember how I said in the tree, it's literally just the decision. You have a choice of either picking or don't.
Yeah. That's basically the same for this pattern of dynamic programming. Like, it's the same thing. Like, it's basically the same idea, but like the operations sometimes change. Yeah. If you go on for example on page 7, I drew it out like the tree, the decision tree, just to try to understand where like the states changed.
Oh, are you talking about what's called the equal sums partition?
Yeah, the problem is called equal sum partition. Yeah.
Okay.
I did the same thing, and I drew it on my board here because I was not visualizing,
So
yeah,
given a set of positive numbers, if we can find a partition it into two subsets such that the sum of elements in both subsets is equal. Oh, okay. Yeah, this is a derivative of like one of the problems that I really like giving. But
the naive approach was clear for me, right? So try all the combinations, considering and not considering one, was clear, the naive approach. And but okay, how can I optimize this? I saw like a few overlapping cases, but anyways, if I just put this into a matrix, it's not gonna solve my problem. I was just if you go on page 7, I drew it out the tree, like on the board.
This one, right?
There's a picture there.
Okay, I would recommend you draw the tree lines because it's a little bit messy, but I vaguely understand what you're doing here.
It's on the page 7. I drew it out on my whiteboard. No, if you can go on page 7. That one.
This one?
No, it's a picture. Like I took a picture.
There's a picture. Okay. Oh, I see. Okay, cool. Perfect, good.
Yeah.
I'm happy with this. Yeah. Okay. So let me just make sure I double check. Given a set of positive numbers, if we can partition it into two subsets such that the sum of elements of subsets both equal. Okay. Yeah. So in other words, the way I would see this problem is, okay, I'm going to create one subset. Now the subset can have element A or not A, element B or not B, element C or not C, or element D and not D, right? And you pretty much figure this out. Just try every single possible combination of like the set epic and then the opposite of that set. Not the intersection, but the whatever the fuck exclusion or whatever it is. But then you realize, hey, wait a minute, it's just like testing. Like if I have a set that has 1 and 3, it's no different than me having a set that's 2 and 4. Because on the other side, must have 1 and 3.
Mm-hmm.
Yeah, and so that's where the memoization actually comes in. At least that's what it would occur to me. But either way, yeah. Let's see what exactly happened here. So what part is the confusion? Let me ask that.
For example, I put it into a square, both 17s, because, okay, the naive approach was pretty clear. But, like, to optimize this, okay, I saw the states, so, like, it can have different sums, like the partitions, right? But how they overlap, this was the only thing I was not understanding. Okay, I understand that the index change, and the sums change. But I was not trying to go like only with the answer, okay, I'm gonna put this in just based on the previous question. I was trying to understand like really where the optimization is gonna
okay.
Where this is gonna improve my solution. So I can argument, and not just copying a previous solution.
Got it. So let me double check to make sure pseudocode is correct. I believe it is. So yeah. So you have the equal value. That's fine. I think. Yeah, your current sum is equal to half value. Yeah, that's fine because it will be equal to each other. That's fine.
Yeah.
If the sum is greater, then it's false. That's fine. Okay. And so here, what you did is, so if index equals to the last element, what? I'm not sure I follow. Oh, I see what you did here. Okay, so you kind of did a little bit different from what the book did.
Yeah.
I see.
I did different.
Yours is not necessarily wrong, but.
Yeah, no. For up until actually from this question, I had all of these questions I did like based on what Grokking is doing. That was the last question I did with using a for, because I realized, okay, this is like the same pattern. I should not go out of this pattern, you know. As you mentioned, it needs to be second nature. So that was the last one, and I acknowledge this.
So you're doing it like literally from the bottom up, not top down. Now I'm starting to see it. It's kind of weird. You're kind of going backwards actually. When I see this, when you're recursing the current index plus 1. Yeah. This is looking weird now. Now I understand what went wrong. So basically, you're relying on picking. You went from right to left instead of left to right. That's basically what. Does that make sense?
So, no, I was trying to go left to right.
Okay, so let's look at this current relationship, right? This current index plus 1.
Mm-hmm.
So basically, you're basically telling me that, hey, okay, I'm on the left-hand side right now. So let's say this is my array x, y, z, a, b, c, right?
Yes.
And so right now, when you say, hey, I want to find out the state at x, you're telling me, hey, okay, well, the current index is going to come from all the elements on the right-hand side.
Yeah.
So it's a little bit backwards. It's not necessarily wrong, I think. Wait, hold on. Am I crazy here? Hold on, let me double check. I think I might be wrong here.
I started with x and then go to y and then z. That was my intuition and what I tested for.
Okay.
I was going forward, not backward.
Okay, no. You're right. So what happened here is I think it's actually this thing here. It should be minus from now. Because
I was doing different. Yeah, my idea was to add it up.
Okay. So you start with current, instead of like decreasing the sum, you start with current sum equals 0, and then you're adding it. Oh.
Yeah, I think like different. Yeah, but then I saw that it's much simpler to just decrement. Yeah.
Yeah, I mean, again, I'm not gonna ding you for this. It's just a lot harder because this, again, like the fact that you kind of go from the bottom up, it's not wrong, but it's just a little. It's not clear to me because I'd rather start from a 0 position than start from a full-on sum. So,
by decrementing, right?
Huh?
I mean, decrementing the current sum, it's better. You think?
I think so. It's just a lot easier because it's easier to say, hey, when I hit 0, it's a lot more intuitive than saying when I hit the sum. It's not, like I said, it's not wrong. Based on like a quick look at this, I don't think you're wrong, but.
I managed to go following this pattern, like only to decrease the sum from the other questions. If you see, like that's the same pattern, you know.
Yeah.
Like, so I tried to make my life simple.
Okay. So the memoization in this case would literally be don't iterate over the same index, array over and over again. Although, wait a minute. Based on this, I don't think this is right either because the reason why is because you'll be adding the same number and over again. Because like for instance, let's say I have my array here like x, y, z. Your code here somehow like a, b, c. Your code here would allow me to add x multiple x multiple times, wouldn't it?
No, but I will try x first with I, right? Yes. Adding up with I, then adding up with z, then like only with z, and then only with A actually, and then only with B. So that's what I will try to do. And on the other recursive call, I'll try the same thing. Yeah.
Oh, you're passing current index in. Okay, as a. Okay.
Yeah, the current index. Yeah.
Okay, so this is a parameter. Yeah. Okay, so you might want to specify parameters. That's why I was getting confused. Okay, then it's fine. Yeah, because so if you say you're gonna pass in like current index as a parameter, then it effectively accomplishes the exact same thing here. If you're like just kind of reverse it. If it's less than some, but otherwise it's just gonna be greater than some. Okay.
I realized that it could be much simple, like with 2 recursive calls. Yeah, just the same as I did in the other one. Okay. From this question, I think I need to do the same thing. Like, doesn't matter like to try to be brilliant, you know, as you mentioned, or overcomplicate.
It's not so much as overcomplicated. It's just like kind of the direction that you picked it. It's not bad, but the intuition I'm trying to tell you is literally just go to 0 when to get your base case rather than going to the sum.
Yeah. I'm doing this exactly this. What you're thinking.
Yeah.
What you're saying. Yeah.
Okay. So let's say that we got to this part, right? I copied this from the grokking. So let's say that I got here, right? So recursive call after choosing the number at the current index. If this number at the current index is at the sum, we shouldn't process this, which is effectively what you did here. So I'm okay with that. A little bit though. Oh, I see what happened. Okay. Do you remember that we had that little chat about like just evaluate at the call, not when you go into the call? Oh. Wait, no, this is probably a consequence of you counting up, actually. Yeah, there's a consequence.
Because I was counting on the function, so there was no way for me to verify before. Only if I put in a variable and verify before, call the recurse.
Yeah.
Recursive call. Yeah.
Yeah, and so it's hard for me to like judge this just because, like you said, like there's a lot of shit going on just as a pure consequence of you counting up. But yeah, but the idea is correct. It's just how do you make it more simple? Yeah. So in this case, the statement we choose is literally, do I want to add, like I said before, do we want to add the number at the current index or not? And if I do, so if, in this case, if the number at the current index is less than the sum, then we just recurse into it, or otherwise we don't go. So then the question now becomes, okay, well then, now that I have that, how do I convert it into a dynamic programming solution, right? So, in this case, what are the two states I'm controlling for?
The index, right, and the current sum.
Good.
Basically, that's what I figure out.
Perfect. So, yeah, now you understand dynamic programming. Literally, now that you have this, now you can construct the DP table.
Yeah, and then I can create like a 2x2 matrix, right, based on the indexes and based on like the maximum sum I can have, and then like map the results for each recursive call. Yep. Basically was this. But okay, this I got like the idea, and I better understand now. But yeah, I was not. But now it was clear to me how this will optimize, you know, the process. But you explain me now; it's much more clear.
Yeah. So now that you have this, I think you'll be a lot better for dynamic programming. I wanted you to at least get your feet wet with it. But realistically, like I'm gonna repeat myself, just so it drills into your head. You're just playing around with states. Get the recursive naive down. Understand how to what you can memoize and just optimize, and understand what states you need control for. Once you have that, you can construct the table.
Okay, and for example, just one exercise here. Can I say that, for example, without the memoization, this is going to be 2 to the power of n, but since we are like computing states like that were previously computed, this is going to reduce. That explanation, sometimes I mess it up, you know. Like I'm like storing the states, and when I will go into the same state, I don't need to compute again.
So you're asking me how to calculate the runtime for each one of these steps. I have no problem.
Yeah, and
go ahead.
In the arguments, just say like how this is gonna be a better solution, you know. So yeah, but anyways. We'll work on this as well.
Okay, so I'm going to tell you, like, this is something that you're going to need to do, but I'm going to tell you this. The easy one, almost always for, like, something like this, for a recursive solution, that you basically have to keep trying every possible combination, permutation, it's almost always going to be power. There's no way around that. When you start pruning, eventually you start getting to a polynomial time. You can pretty much guarantee, to some degree, that it'll probably be polynomial time on the top-down, bottom-up. And then when you go to DP, it's almost always going to be some linear time. Or in this case, like, it'll be, it'll be linear time along 2 dimensions. So in this particular case, I think for most people, they're not going to ask you to do the time and space complexity of all of them. But because, essentially, if you think about it, once you construct that table, that 2D array, all you're really doing is iterating through that table. So there's your time space right there. So I would say the intermediate step is probably not necessary, but it's a useful exercise to do. I'm going to give that to you, and then we can talk about it on Saturday. but I want you to at least try to walk through it. Does Grokken give you the time space for the optimized?
Yeah, they do. They do. It's like n by n times like it's like the size of actually. Let me check here. But I was not understanding why they like how to explain this. I was not understanding their explanation because a lot of their solutions was bottom up. You know, but it's the same idea. But so for example, yeah, the above solution has a time and space complexity of O n times s, where n represents the total number of n total numbers, and s is required sum. You know, so
I see.
I was like, I need to really understand how to explain like better solution.
Okay,
I was having a hard time.
Okay, let me see if I can explain it to you, and then let me see if it just clicks in your head. So let's say I have my tree again, right? Let's say I have my tree, right? Now, of course, every single branch. Let's start with the order 2n, right? It's very obvious because at each branch, you're going to have either a choice to do something or not do something. So that's 2, and then n just represents. Okay, well, I'm going to do this for every single element with n elements, so to the n, right? So now the reason why it's no longer this is because I'm going to start pruning some of the branches. So which means that I'm not going to be able to repeat myself, right? Okay, so the question then becomes, okay, well, if I'm not going to repeat myself, then effectively what happens here? What happens is that I just need to check the sum minus whatever amount, whatever pre-computed thing here, right? So in other words, that's going to be sum s, correct? Oh wait, hold up. Let me switch this. This is okay, sorry. So in other words, I'm gonna recurse. I can only recurse to element, s minus, let's say n, or where n equals 1, 2, 3, 4, 5, whatever, all the way up to s, or s minus or whatever. The point. But I can only visit each one of these once, because I've already saved the state, right? So I know that at least my runtime on that dimension is going to be s. So then the next thing is just going to be along the index. Okay, well, like it's the same exact principle. Like for the index, I can only visit index, or say index plus, let's say j, where j equals 1, 2, 3, all the way up to whatever the size of the array. Yeah? And I know that, again, it's the same exact argument. I can only visit index 1 once, with a combination of S2, right? I might be able to visit index 1 and S3, and it might be different from index 1, S2. But once I get those answers, I will never have to visit that state again. Does that explain why I'm getting order n to the s here? Or n times s?
Okay, I'll need to practice more like this. But yeah, I got the idea.
It's just getting an intuition for that. I think I made it simple, but it's like now it's left to give you an understanding. Of course, I can help you with this, but this is like the simplest way I can explain it. It's like I'm in a state that I will never ever repeat. In which case,
once completed.
Yes.
Yeah, once completed.
Yes.
Yeah.
So the question then becomes, how many states am I visiting?
Like, from my understanding, the number of indexes, because it's the depth of the tree, like of the tree of recursion. Like we cannot go more than this, from my understanding.
Yeah, because like I said, like we've tried every single possible combination, right? This represents the whole realm of things that I can ever come up with. All we're saying now is some of these branches might not be viable anymore because we have already visited that state. And once we visit that state, we will never repeat that. So in other words, how many states can we visit? Do you understand that chain of logic?
I think, yeah. It's a little bit confusing still, but I'm starting to.
Yeah, let me see if I can come up with I know I'm kind of repeating myself, but I think this is like super important for understanding.
But yeah, I will like rewatch this. Don't worry.
Okay, that's fine. So let me actually see all your other non-dynamic programming problems. Is it at the bottom or?
No, actually, all of the problems I did was dynamic programming.
Okay, what's this mock interview then? Is this from last time?
Oh yeah, that was from like one from today and the other from yesterday. I was doing before, yeah.
I'm curious how you did on them actually. So which one was the one that you did yesterday, or let's say you know what? Which one was the one you're most proud of?
I think. Let me just see. Yeah, I think that one. Minimum elements.
Okay.
Yeah, because the other was I took too much time to create the solution. Was clear to see. My friend even said that I got like the same framework, to create all the examples and like draw it out what I want to do, but I just wrote my first line of code in like the minute 21. Yeah, because I was making sure that bulletproof, like what I want to do.
I understand that.
Yeah.
Yeah, I have no problem with that right now for you. Like I said, if it is very obvious to you that I don't need to test this, like you're like basically confident that it's just like, oh, I'm testing this just for the sake of testing. At that point, you can probably get away with like not testing it, but like it'll be an instinctual thing. You'll recognize that situation because you'll be able to see it.
Yeah, I'm still like doing the thing you suggest, like to do the hypothesis of things that I may want to test or not,
Yeah.
before creating the tests, the actual tests. But yeah.
I mean, I definitely want you to get faster, but it's like this is not something that you can force. It will be something that'll be very apparent to you, and it'll be very easy to do. It's waiting for that moment, and I'm hoping that happens at some point. So, let's see. Given an integer array num size n, return the minimum number of moves required to make all array elements equal. Okay, so let me see example. In one move, you can increment, decrement an array by 1. Okay. So you have an array of 1. Yeah. Okay, this case, okay. I don't understand this problem, actually. So let's see.
Let me try to explain. For example.
I was going to read the examples first, because I think the examples should be self-explanatory. Yeah. Okay, cool. So example 1, 2, 3. You only need 2 moves are needed because... Are you... explain the minimum number of moves required to make... What? Each move is an increment or decrement. Got it.
Yeah.
Perfect. Okay, I understand.
But basically, that was it.
Okay. There's no element. There's one element. All elements are the same. Return 0. Okay, so these are your base cases. I'm okay with that. So then you're trying to make all the elements equal. Yeah. So each operation, you're minimizing the number of operations to make all the elements equal, and you can only go increment or decrement. Perfect.
Yeah.
Yeah. Good. So let me see here. Okay. So this is you trying out some ideas.
Yeah, I was trying first to go with the how to say English, the mean, right? The mean, like of all of the numbers, right? The median. I don't know how to say in English.
Yeah.
But that I felt into a case that this would not work, right? He gave me this example like of 10086. It was not going to work.
Yep.
And then I thought about, okay, so basically I can sort the elements, right? It's going to increase my time complexity, and then take that's a mathematical term, like take the element that appears in the middle. I don't know how to say this.
Median.
Yeah. Just to take the what you said.
Okay, that's not bad. That's not a bad situation.
Yeah.
I understand.
And take the element that appear in the same and make all the elements be equal to this one, like by adding to see like the difference from every element from the array.
I see.
And there's like an edge case in case the number of elements is even or odd.
Okay.
Because the rule said if the elements are even, we should take the mean between the two middle elements, and consider this as the middle element. And otherwise, we should just consider the middle element for odd elements. So that was the edge case. Then it's just to calculate the differences. Yeah, that was pretty much it.
Okay. This problem is how to describe it. It's not obvious to me. I understand why you thought median and mean might be the way out, because you're trying to calculate increment and decrement all the way to a number, and then just use that as your branching point, which I personally don't have a problem with, actually. I understand why you made that association, but to me it's not a logical association, it's just an instinctual one. So to me, the way I would
Pretty
approach
much.
this problem, and maybe this will help you give some perspective of like where I would expect a candidate to go. I would expect a candidate to just follow the same formula. Naive solution is to try every single possible number in between minimum maximum, and then try the increments and decrements for all of them in order to get there. And in which case it's just gonna be the difference, right?
For all of the elements.
Yeah. So like for
Okay.
instance, I would try like if in this particular array 1 and 10, 2, 9, I would just try 1, 10. I would like try 1, 10, or 2, 9, and then just try every single element and try to increment it. So let's say my target was 10, right? I'd increment this by 9. I do nothing here. I'd increment this by 8, and I increment this by 1. And then okay, let's try to take the next number 2, right? I would take this one, increment this by 1, increment decrement 8, 10 by 8, and then decrement 9 by 7, right? I would still follow that formula, but I think the problem is that you are trying a bunch of different numbers and decrementing. You're just trying it out for every single one, right? But there may be a smarter way to do it without having to try every single element. So you get basically an order n time essentially.
Yeah.
Yeah. So then the question now
yeah,
becomes how to get one.
I understand perfectly.
Yeah. So that's.
Also, I put in yellow, like, here's comments. Like, he even said the same thing as you.
Yeah, see, I was like, I've never seen this problem before, but I'm literally just saying, okay, what's the naive solution? So it's like you could have tried that, and then once I tried the naive solution, then I'm realizing, hey, wait a minute, is there a way to get constant time? Like, not really. The only other thing I could do is like log time, but these other ones are not sorted, so I can't just do like a binary search. So you see, like the checklist I'm going through is like, okay, well, the naive approach was just literally just try every single possible element. Log is out because I can't sort it, and I need to come up with some kind of if I want to come up with constant time, I need to have this like hashed already, or like have some kind of like constant lookup that I can, some previously known fact that I can use, which unfortunately there is none. So to me, it's very obvious that it's an order n solution. But you see, like literally just if you just followed the formula that we've been working on, is literally just very easy, and I think he would have yeah, he would have given you the answer, I think, or at least help guide you. So in this case, it's just like you abandoning whatever we practiced. It's like it's kind of your instinct fooling you. I think like I said, I understand why you said median and mean. I perfectly understand, but like I said, it's an instinctual trigger, not a logical one.
So I should not have followed my instincts. Yeah.
It's not so much that. It's just that in this case, your instincts went wrong. But your instincts should be calibrated in a way that it should be very easy for you to follow that roadmap that we've been working on, right? So it's like naive solution test, optimal solution test, blah blah blah. Your instincts should automatically like approximate that trajectory already.
But the thing was, I thought that this was the naive because I have to sort, and
Okay, then let's have that conversation. So let's say you thought the naive solution was to sort, get the median. On what basis?
Yeah.
How does that get you the answer? Can you prove that will get me the answer?
No, I mean the median, right? The median, not the mean.
Yeah. Like I said,
because I have to sort.
Sorting is just a tool. How does that help you? Like I can sort any array. That doesn't mean it's going to give me an answer, right? So what does sorting here give me?
A way for me to take the elements from the middle.
Okay, and how can can you guarantee that choosing the middle here will always result in an answer? I can already think of like a counterexample already.
I can do like a test case
Sure.
to prove.
And I can think of a counterexample already.
So imagine I'll have a lot of zeros.
Yep.
And 2.
Okay.
Okay. So imagine they are sorted, but yeah. So that's a counterexample because I have to
Sure.
increment. Like the median number is 0, so which means that I have to decrement all of them by like only this one by 2. So from my answer, this is gonna be like 2 movements, right? But the correct one, actually, let me just think about other counter example. Yeah, because this is gonna be the minimum number of. No.
To be fair, my test case is not gonna is a little bit clever, but and I don't think most people would think of it. But let me. You want me to give you the? You want me to give you one?
Yes, please.
So what if I had int dot max int dot max and 0?
That should be a base case.
I mean, it's not really a base case. The reason why this is clever is because in theory I can just do buffer overflow and just add 1 to all these, and this would just go, or I should say like this is a negative int dot max, and I can just do that. I technically just do buffer overflow on this, or decrement the int max 1, so this would just be equal to 1. Although it's a very nuanced one. But in this case, what your solution would produce would be int max. Do you understand what? Or should I say 2 times int max actually?
Yeah, because okay, I was trying to take the middle element, and this will be int max, right?
The reason why is because you take the difference between int max and int max. You're just gonna get 2 times int max, assuming that you can actually fill this, right? Because your median will just be int max, right?
Yes.
So your solution would say 0, 0, and then negative int max, minus int max, and it's like, oh yeah, that's gonna be 2 int max, so that must be the solution. And I'm like saying, just call the buffer overflow. I mean, it's a little bit sneaky, and I don't think most people would think of this one particular example, but this is like the first one that came to my head, or second one really. Although although the interviewer would probably hate me for that, but. Anyway, my point here is that...
I need this. Yeah, I need because I need to be prepared. That's not I hate you or not.
Yeah, so to me, it's all about making sure that the very first solution that I bring out, I can guarantee without a doubt in the world that I can prove it will get me the right answer. In this case, your instinct is just telling you this will get you the right answer. But you want to at least start from a very basic, very solid point. So in this case, it's like if I want, let's consider like I'm writing a piece of code, right? I don't want to be clever my first time around. I want to make sure that the first idea that I write is going to solve every single possible situation I could possibly ever run into, even if it's like this really weird, dumb case, right? And the best way to do it is just try every single possible combination. That's almost like 99% of the time the correct naive solution. So. In other words, I would say you didn't do good on this at all because you did magic bullet, and I mean we talked about this before, but it's just like train that instinct. That's all I can say.
He said like, if you the same thing as you said, like if you create an idea, try to see if there's a more like not so optimal, but like when we're talking about the solution, and I remember as Edbert said like. Just try to think about solve the problem. But the first thing I thought of solve the problem was to take the mean, So yeah, it was kind of wrong instinct.
Yeah, it's being over eager, and it's like, oh yeah, I can just do. I'm looking for the medium because you've probably seen something like, oh well, the shortest distance between 2 extremes or like whatever list is median. So I understand where that comes from. It's just that it's just plain wrong.
Okay.
Well, yeah, like just make sure that if your instinct is going to do that, then make sure that. It just means that you have to correct your instinct and what flags you need to look for. So it means that make sure that your associations are right. So remember what I said to backtest a lot of your claims? This is probably one of the, or backtest a lot of your patterns and instincts. This is a good example of where if you don't do that, it will fuck you up.
Yeah. Actually, one thing, just to take your point of view, do you think it's like I think he got like 3 offers before he joined to Amazon, like Bloomberg, Microsoft, and Amazon. Do you think it's good like those mock interviews?
Yeah.
Because I think they're good. He gave me like valuable insights as well. Not so like direct and practical as yours, right? But it's like his perception.
Yeah.
His perception is about, oh, your framework of solving questions is pretty much the same. You just mess it up in the time, and like only those things. Do you think it's valuable?
I think it's good because I think it's pretty good because one, I'm always in favor of learning from people who are better than you and who can get consistent results. Those are the two things. Once you have that, then it's like, okay, well, obviously this guy's doing better than me. I want to clone whatever is working for him. And notice that he literally said, okay, you pretty much arrived at the same framework that he uses to get his offers, right? So in other words, you should see similar results or pretty close to similar results as him, which means pretty consistent offers or 3 offers, right? The only problem is that the only difference that happened was literally you had a bad instinct and that fucked you up. And notice like the moment he said, oh, you tried to do a magic bullet, you instantly already knew this is something we talked about. He's like, oh yeah, that's something. And that's a very good sign. That's a very good sign, meaning that, hey, you know how to correct it. And that you know, like, it isn't immediately what you're doing wrong. All that's left is for you to actually correct it. So I'm always in favor of working with people better than you. And I think he very obviously knows what he's doing. Or at least he's
from the same class as mine, so I remember he got the very big grades. Like, anyways.
It's a small short spiel. Just always be humble and always learn from people better than you. It's a lot easier than trying to figure out this shit yourself.
For sure.
I'm a big fan of just cloning what people have done and how they think because they've already put the hard work. Why would I want to reinvent the wheel?
If I can get 80% of his results, it's gonna be like 2 offers. It's more than enough.
Yeah, exactly. You don't even have to get like 80% of it. You can just like I always say like even 70, like or 100. You don't need to clone him 100%. Although that's like probably what you might want to consider doing, and depending. But I mean, like we already have our own stuff going on here. But yeah, like if you can even capture 80% of his results, what? Like that's already like 2 out of 3 offers at minimum, or 2.5 out of 3. I still think that's pretty good.
Anyway,
so
2 is good.
Anyway, so. That I would say be very, very careful of that. We do have 8 minutes left. I don't know if it's enough time to review, but I'm going to say keep going on this trajectory. I think I like what I'm seeing right now. I think me forcing you to do that framework is a lot better. All that we need to do left is just, give that time. Let that engine run, and then see if you get that instinct. I do want you to try and predict for these, like outside, if you're doing non-DP problems, I want you to try and predict what will happen. Like do a small 1 minute write up of what you think will happen and like what you need to do. So,
okay,
let me write that down for you. When doing non-DP problems, try to spend. I would say spend 15 to 30 seconds and predicting what will happen. Like it could be a right prediction, it could be a wrong prediction, but this is just more or less trying to train your instinct. So it's like when I say what will happen, it's just like, hey, what do I need to test? Will I need to test a lot or a little? What pattern might I want to use? Where should I look? Etc. Basically, where do you think your own thinking is going to go? Where is your own thinking going to go? And then after that, just execute. Execute as we have been practicing. And afterwards, compare. Compare your prediction. That's it. It's a small 15-30 second thing. Your prediction should not have any bearing on what you actually do. Although I think it's hard because you need to have the mental discipline to not let your prediction guide you like that. I mean, in some ways you are letting it because that's what an instinct is, right? But at the same time, you need to have the discipline to say, hey, wait a minute, this is not logically making sense. Let me slow down for a minute here and let me override that prediction because just consider this like a non-biting, but it requires a lot of mental discipline to do. And I don't know if you can do
one thing. In the he stated this thing of you just jump to the magic bullet solution.
Yep.
And in today's mock interview that I did with him, he said, when I was creating the solution, I figured out about using a hash set or a heap, but I was not sure. And then he even said that was good that I did this. I did a step back, and analyze. Okay, so what I wanted to do here on my walkthrough. Okay, I need to have these elements kind of sorted all the time, So he said, you should to do this every time, So even don't ask for the interviewer, just try to create the conclusion about yourself and try to answer your questions by yourself.
Exactly. Think of it like having a conversation with yourself. Think of some guy who's sitting across, not just the interviewer, even when you're doing anything or any problem, just like imagine there's some guy behind you saying, "No, you're wrong. No, you're wrong," and you have to defend yourself.
Yeah.
Yeah.
Okay.
Yeah. Anyway, so I want you to give that a try. Let me know if it starts throwing you off, or you feel like, fuck, my prediction just keeps roping me in and forcing me into a hole. And then we'll stop that. But essentially, basically what we need is just time to let this go.
Yeah.
As long as you practice right, that instinct will come. So, but be very aware, be mentally aware of what is happening to you, and saying, "Oh wait, fuck, this is happening because," and I'm not sure what's going on. Then ping me about it. But always remember, like there's maybe imagine there's some random guy saying you're wrong, and then you need to prove it to him.
I imagine that is you saying this.
Yeah.
Like, okay, Edward's saying no. Yeah. Anyways.
Yeah. No, I was like, I do the exact same thing. If you want me to, if you have time, there is some reading that I think you might enjoy. If you have if you want to relax to some writings by Charlie Munger, I can send you that to you because I think he does a lot of really good philosophy and very easy to understand speeches about this. And it's only bedtime reading, but I think some of the stuff that he says might actually make sense to you.
I think it's good if you can, please.
Sure. There's ping me after this because I do have another guy after you, but send me a reminder to send that to you. Okay.
I will. Yeah. Just the last thing. It's not about technical stuff.
Yeah.
My classes start, and I have 2 classes on the week.
Okay.
What I was thinking is just for this interview process, we are just going to the first phone screen. I will go to the college because my classes are at night.
Yes.
Right. So 2 of them are at night, and I'll be for 30 minutes, and then go to the library, do more exercise. So just to be aware about this.
Okay, that's fine. I'm going to assume that you basically shave off about 3 hours. I'm going to say 3 hours. Yeah. I will update. I'll expect that you will decrease by 3 hours. So,
yeah.
Hold up. Let me actually bring up the sheet. Let me bring up the study plan. Give me a sec.
And I can start earlier or 7:30.
I want you to.
Totally okay.
I still want you to get a good amount of sleep because what is going to hold you back is if you start making a shit ton of careless mistakes. I do see you. Do you still have work? Let me ask that.
Yeah, I still.
Oh, you still have work, and then you're going to study in the evening. Okay, so basically, this entire time is going to be basically half this time is going to be knocked out. I think.
Hold up. Let me just see here. Okay. Okay. It's totally okay for me. Hello.
Yep. I see. Okay, so let me see. So you think it's a fair approximation to send to I'm going to knock this out. I'm going to knock out 2 hours actually. And then hopefully you can streamline dinner. Ideally, what would happen is that you streamline dinner like this. Is that what you have is that okay?
2 days of the week. I can do the full 4 hours. Okay. But there was gonna be 3 or 2 days. I just need to check here. Okay. It's gonna be none more than 3 hours or 2.5 because of those classes. 1 day is guaranteed that it's gonna be 2.5, and the other is 3 because I have 1 class. Yeah.
Okay.
Let me just check one thing here.
Yeah.
So I can give you the precise information. Just one moment. But yeah, I'm trying to put into work.
That's fine.
Because man, that's number 1.
Yeah. I get it. So that still gives us 1.5 hours. This is certainly grueling, but it's not impossible. So this gives us about 2.5 hours, 2.5 hours each day to do things. So this gives us 2.5 hours. Still okay amount of time.
Only Tuesday. All right. Tuesday I have 1 class. Thursday, Wednesday I have 2 classes, so it's the whole night from 7 to 10:45. But I can get in the house earlier, and study 1 hour in between on the library. That's totally okay for me because that's my priority.
Okay.
Thursday there's no class for me, and Friday there's one class that goes from 7 to 8 p.m. So those basically. So 3 days of the week, 1 day. I can guarantee 1 hour, 1.5 hour, but 2 days I can guarantee 3 hours, and the other is 4 normal hours.
Okay, that's fine. So I'm gonna basically expect you to not give me 2, 3, probably 3 problems, 3 or 4 problems less per week. That's fine. But I know you're probably gonna spend like a lot of time like what's it called on transport between buses. So what I would like you to do is like to constantly review the notes that we've done, like like the stuff that I've highlighted. I want you to put that on a sheet and just kind of like read it, and then just like kind of look back at some of the problems that we've done, or like the sheet that our problem sheet, and just remember say, oh yeah, I remember that mistake. I could have prevented it by doing this step. Just kind of like focus in a little bit on your mistakes, on past things, and you just like constantly remind yourself that hey, I should not make this mistake. I think you just do that can help.
Active recall about my mistakes.
Exactly. And it's just like, oh, now that I know I'm smarter and better, this is the way I would do this problem. Check. And then maybe a few notes, and then just try it out later on.
That's a good thing.
Yeah.
I will do this. I will actually print and get on my notes.
Yeah. And the checklist should be like no more than 1 page, I think. In fact, if you do it right, it should only be like half page. But it should be like, it's like I see that one sentence or something, and then I see, oh, well, there's the 10 ideas that are attached to it or something. So
yeah.
But yeah, I try that for a little bit. Try that for a little bit. I know we're gonna have like Microsoft in about 10 days. So yeah, or like a week actually. Shit. I don't want to recommend that you skip class, but you might have to.
But I can totally, because that's the first week.
Okay.
So that's what I was thinking. Today I skip a class.
That's fine. I would say if it's like not gonna hurt your grade too much, then probably skip and really focus on it, because we have 1 week to make this happen. And I'm gambling that you can make this happen too, like for Instinct, because I mean we have Amazon coming up too. I mean too bad about Facebook, but shit happens. So let's hopefully get this.
You're gambling. Okay, so
I'm really gambling. It's like at this point there's not much we can do in a week other than like and hope that your instinct pulls through. So if it happens, it happens. It doesn't, it doesn't. We still have one last shot in the barrel. So don't pressure. Don't feel pressure to like cut corners. That's the worst thing we can do. But I'm gambling in the sense that I don't know if this will work, but I'm really hoping.
Okay, I will do my best. Yeah. You can count. I can count with this at least.
Okay.
Yeah. Anyways.
All right. Cool. All right. So I'll let you go then.
Okay, man. Thank you very much.
All right. Bye. Bye. All right. Cool. Let's see what some of y'all said in the stream. Like, I'm fingers crossed right now. I'm like, is he gonna make it? Like, this is the point of like, is he gonna make it? And then is he actually gonna do well in the interview? And I am right now, based on this, I'm like 60%, 65% right now that he can get the instinct. And then once he gets that instinct, we're gonna have to like basically execute on the seat of our pants. Holy shit! Like, I don't understand. Like, I'll say like before we jump to our surprise client, our surprise guy. Like, it's about 65% chance that he gets that instinct, because it's like it seems like he's made a lot of good progress with the framework that I've given him. It's just, will he be able to make that instinct, that jump? And it seems like once he got that, it's just like, how to describe it? It's either you get it or you don't. And I can't tell you how I'm calculating this. It's just 65% chance that he gets an instinct. And once he gets that instinct, I think he has he can probably get like 70% chance, 80% chance of, I would say more like 70. Yeah, based on my historical averages, 70% chance of Microsoft. Of passing the Microsoft interview, actually. The reason why is because we haven't actually done any calibrations on previous on-sites. So it's kind of hard for us for me to say, hey, you need to adjust here. So it's done by the seat of our pants. I will literally be, I have no idea how this is going to fucking turn out. Holy shit. Like, it's like, 65% chance you get there. And then if you get there, then 70% chance. If he doesn't get there, then the probability drops down to like 40% in my head. Or less. This is like we're knife's edge right now, and I don't fucking know, man. It's so fucking stressful. Fuck. Oh, god damn it. We also kind of botched Facebook as well, but it's not so much we botched it. We were like kind of forced to take the Facebook interview early, and we couldn't defer it. So it's kind of been like shit. So then we kind of lost Facebook. I mean, like, I already knew, and I told him going into the Facebook interview that he was not ready, and I think that kind of showed through. But we were kind of like forced in that position to do our best. So I hope we do a little bit better on Microsoft, and then Amazon. Fuck. Okay. Enough being stressed. I'll stress over this and get a fucking beer later. Wait, hold on. I'm gonna get a fucking beer right now. Screw this. this. I'm drinking. Actually, I got a cider. Screw it. Pray for me, guys, and pray for my bladder. Oh no, not bladder, but liver. Okay, anyway, let's bring on my next guy here. Let's see, Zoom, where are you? Okay, let me start the Zoom meeting. Perfect.
Recording in progress.
Check my... No.
Recording stopped.
Okay, it says waiting room, really? Okay. Hey, man. Hello? Hello?
Hello.
Hey, so what's up?
Hey, how's it going?
Hey, doing good, doing good. Yeah, just let you know this is being streamed. I guess say hi to people.
Hello.
Hello.
Welcome to the stream. Glad to be here.
All right, cool. Yeah, I guess for this one you kind of wanted to be a little bit anonymous. So I'll let you introduce yourself as what's it called? Yeah, just introduce yourself, what you want people to know about you, and kind of like what you're here to do today.
Yeah, so I'm working at, you can kind of consider it to be like a unicorn startup of sorts. I'm relatively new at the company, and I have an opportunity to laterally move to a FANG company, and I think I'm pretty torn about this decision because I like a lot of things at my current position. And there's a few things that are kind of drawing me to the FANG company, given that I'm relatively early career as well. And I think, yeah, I kind of just, would like to kind of talk through the pros and cons and get your opinion on the situation, and hopefully that's applicable to other people out there as well.
Yeah. I think everyone's in a kind of a different situation. Like you said, you're early on in your career, and I think a lot of people who are watching this are also very early in their career, so they will face this problem and situation, I think, at some point. And it's very common very early on. I would say like one of the reasons why a lot of companies are hesitant to hire new grads is simply because they're gonna face, like, a lot of new grads face the exact same question, right? Like they want to like try to explore what's out there already, and so all the investment that a company puts into them, like, is just lost because the new grad decides to shift gears, right? I mean, this becomes a less of a problem because later on in your life you're gonna have like kids, wife you gotta take care of. You can't jump jobs like that too often. But yeah, I think that this will be immediately relevant to a lot of people over the horizon. So you do have a like I said, an opportunity. So my question to you will be, well, first let's weigh the pros and cons in your head, and I'll tell you what my checklist is. So let me ask first. You have an opportunity. What makes this opportunity compelling? Is it just simply the FANG name? What's going on through your head for pros and cons?
Yeah, so part of it is the FANG name brand. When I joined this unicorn, I didn't necessarily, and previously before that, I didn't necessarily buy into the FANG mystique. But since joining, it's definitely actually changed my opinion, just hearing how people internally talk about it and noticing like people who came from FANG who work at this unicorn. There's also like a difference between the engineering clarity, I guess, that they bring versus people who didn't in general. So that's part of it, but maybe less important. I think the main thing is that as like someone who's relatively early career, I'm trying to optimize for learning opportunities. And I think this is where my big conflict comes in, because at the unicorn, it's still a startup, so there's a lot of like opportunity for ownership and driving things forward yourself.
Mm-hmm.
But because it's still a startup, it's also very execution driven. And so there's not a lot of space for learning outside of doing, which is, of course, everyone says like learn by doing, but that's not necessarily always the best strategy, I think. And I
Mm-hmm.
know at this particular Fang company, um, there would be quite a bit of room to learn and develop myself as an engineer. And so I think that's kind of what is drawing me towards the Fang and away from the startup. But I feel kind of conflicted about this because I don't really have any significant complaints about the unicorn, um, other than just that it's execution focused, which I can't blame them for, and I think is totally reasonable.
Mm-hmm.
Um, so yeah, I'd say it really just comes down to like which where will I learn the most and how will I propel my future self forward the most? And if that's at a unicorn startup, then I think I should stay. If I think that's at the Fang company, then I think I should go. And that's really, I think, the core of what I'm debating right now.
Mm. I see. Okay, so let me kind of walk you through my thinking first. Um, to really answer this question, you have to kind of like know yourself first. It's like, what's the best way to learn about something? Yes, doing is like one way to learn, but the thing is that if you do it wrong, it doesn't matter because you're just gonna learn the wrong thing, right? And so for me, the best way to learn, at least what works for me, is not like through books, not like through reading, even though I read a lot, is literally just copying people. And so one of the things I like doing is literally just find people who are really, really good and copy their thought process, try to model the thought process. And I find that as long as I have people who are highly competent, there's always something new to learn as long as I keep working with them. So let me give you a solid example from my own experience, and maybe this might make a little bit more sense of because like you might think, oh well, if I have new opportunities, then why I just learn through those opportunities? Well, when I made like some what's called career changes, there was the first team I one of the teams I joined had a lot of opportunities. Like there was an unbelievable amount. Like there's like I could pretty much by the time I was done with it, I could pretty much have had the entire team in the palm of my hand, believe it or not. But then I kind of realized that what was making me unhappy and why I wasn't learning was literally just because I was going outside of the team just to learn. I was literally trying to find people on other teams who knew things, right? Because like whenever I had a question or something, I just straight up said, I just kept asking them like, hey, okay, you guys have been on the team for like 3-4 years. How does this work? Like I don't know. Like wait, I have so many opportunities, but I don't know how to actually execute on it. That's kind of the problem I see. I think with most people is that it's not so much the opportunities that you're given; it's whether or not you can actually take control of them and seize them. Because it doesn't matter if you have the opportunity to fucking write something amazing and fucking cool, if you can't write it correctly and it just ends up causing more headaches, right? I mean, sure, it's a mistake that you'll learn, but then it's like, well, the question is, what's the right way to do it? And if you don't learn the right way, then you just end up learning the wrong things. And you learn the wrong things, you build bad habits. You build bad habits, that tanks your fucking career. And that's the way I kind of see things. And I don't know if you see it that way too. So going along with that vein, let me ask you, how do you learn best?
Yeah, so I think I learn best from a combination of my own exploration
Mm-hmm.
and sort of what you mentioned by leveraging like peers who know more than I do. And so like learning from people, but with exploration myself as well. And I think that's a lot of what you hit on is kind of my concern at the unicorn, where I don't really know if I'm actually learning best practices or not. Um, and everything is so execution driven. There sometimes isn't the thought that goes into like, is this really designed the right way? Or like, is this really a scalable design? Or like those questions are in many ways secondary right now. That being said, I will say that my peers that came from Fang companies in particular, not exclusively Fang, but the high quality peers at this company are definitely people that I'm learning from and that I look up to and are willing to like help me um, learn. So it's yeah. But to answer your question, I'd say I learn by exploration and doing, and then also leveraging peers around me. And I feel like when I've learned the worst, it's when I felt like I was lost and on my own to figure something out.
Mm-hmm.
And then add in like a deadline to that equation,
Mm-hmm.
and you get a very stressful environment. Like I think the most stressed I've ever been is when I needed to learn something. I didn't have the resources to learn those things, and I was expected to learn them by a certain time and have it done. Um, and so if you don't have that space to learn, I think it's can be quite frustrating.
Mm-hmm.
Um,
I understand your concern. Let's walk through a checklist because usually these things are more complicated than they seem. So first of all, you mentioned that there are high quality people in the company that you really respect, look up to, and you learn from. But at the same time, you also say you're kind of lost on your own and you don't have the resources to learn the things that you need or like have any context on like the code base or whatever that you're working on. So to me, it seems like there's a kind of a diametric there's kind of a conflict here because how are you learning from these people if they don't know anything about what you're working on or can't give you feedback? So that's my first question.
yeah. So it I wouldn't say that I yeah, maybe I didn't phrase that correctly. A lot of those experiences haven't happened at this particular company. There definitely is a certain degree of that goes on where it can be hard to find um, like things aren't documented super well, and so a lot of what you end up having to like ping someone, and sometimes it can be hard to get in touch with them or like find what you're looking for. So there's definitely some of that.
Mm-hmm.
I would say that overall, though, that people are generally helpful and yeah, are willing to teach and well, maybe not teach. They're willing to give you the answer to whatever your question is, and
Mm-hmm.
do that in a helpful manner.
Mm-hmm.
So maybe I was more referring to like generally I was thinking in previous experiences outside of this company, when I felt the most lost is when I feel like I don't have guidance and there's a deadline, and I feel like that's the most stressful situation to be in. And I
Okay.
haven't experienced that a ton at this company, but a little bit.
Okay. I understand. So let's dive a little bit deeper into that. So you mentioned like documentation. I'll tell you this, like even at big companies, there's still a lack of documentation because code base changes so many freaking times, and there's always so many what's it called? Like there's so many changes, right? So no one is gonna know exactly how anything works. They might have an approximation of like, oh, last time I encountered this kind of happened, but I have no idea how the internal guts of it work. So document like semi-perfect situations. That's the best way I can describe it. Like semi-perfect information. Um, wait, what's the incomplete information or whatever you call it in machine learning? That's basically what you're operating under, right? And so,
Mm-hmm.
and so, the people who are giving you this information are they people who actually understand? Like, oh, they can complete the documentation that isn't there, like it's tribal knowledge, or it's like I don't know what's going on. I have zero experience with this system. I have no guidance to give you. Well, which one is it? Is it like they can complete the picture, or they just have nothing?
Uh, I would say it's more the former, where they can complete the picture in general. Yeah. And people from other teams also will jump in and help complete the picture too.
Okay. Yeah, so that's actually very normal, believe it or not, even at big tech companies. So I have faced this myself when I was like trying to even switch teams within Uber as well. And that never really goes away. The trick is actually to make sure that you can learn and have a system that will basically allow you to get to the right answer or figure it out as fast as humanly possible, right? So for instance, mine is really just find someone who seems to know a little bit more than the rest, and then just try and copy the way he approaches things and just kind of like how he does things. So one of the things you could like if he's working on a similar area than you, then you can or has worked on some previous diffs, then one way you can do it is just by looking at all his merge requests and everything in the what's it called in the Git history, and just see, hey, he made this changes, and just kind of ask him about it. That's kind of the way that it works for me. But it sounds like you're kind of expecting the whole system to be handheld for you, and then you're just kind of like, oh yeah, this is how this works. But I would encourage you that the proper way to learn isn't like, oh, how does this work? The proper way to learn is how can I learn what I need to know faster. And is that something you ask yourself, or is it just more like how does Kubernetes work, or how does this work, or how does Docker work, or something like that? Which one is it? Let me ask that.
I'd say I actually focus on the latter, learning how to learn. I would say that's part of the desire to go to this other company is that I think they might be much better at that. Like the Fang company might be much better at providing infrastructure and resources to do that. Like one trick, and this might be useful for people listening. I actually have a habit of writing out a Slack, like a message to someone, and with a question, and then I won't send it. I'll write it, and I'll read it, and I'll ask myself, like, can I answer this myself? Like, can I answer this question myself? And what do I need to know? And how can I get the information to answer this question before I hit send, to try to like stop myself from just asking people like, oh, hey, how do you do this? And I find that super helpful. And for people listening, I would recommend giving that a try. Especially like when you're first starting out and learning the ropes.
Mm-hmm. I think that's a good one too. I do exactly the same thing, and I'll stop myself and like, hey, wait a minute, this seems very obvious, and I feel like this should be something that's documented. And one of the tricks I use is literally, okay, just along with the message, write down two or three things that I've done to try and fix the problem myself. And you kind of repeat this for like basically 6 months to a year, and eventually you kind of have walked the entire circle of what most people walk around. So let me give you an example. Like, if I'm trying to figure out how like our CI/CD pipeline works, I'm literally just gonna write, okay, how does it? I can't figure out what is triggering this hook, and it's like I've looked at like what our backend does. I've tried to look at different pipelines, and this still doesn't make sense to me, because it calls XYZ, blah blah blah. And then I'll ask someone, and then you're usually they're more willing to help you once you can show them that you're thinking like that. But it definitely takes a while, only because like you said, like, and like I've observed, is that the information is incomplete, right? But once you've gone down those roads over and over again, you kind of realize, hey, wait a minute, okay, this is where I go for XYZ, this is where I go for this other piece of information, and so on and so forth. And eventually you just kind of like start like becoming a little bit more familiar with the documentation of what is and what pieces of information are available to you and which ones aren't. And that's actually part of it. That's kind of like the thing that no one really tells you about, is that you're almost always operating on imperfect information. It's really like even if you've been on a team for like a long time, I would say like even the most knowledge I ever got was like 80%. Like even when I was at Apple for like 4 years and I like reorganized the code base and everything else, I only understood 80% of like what exactly was going on in our code base. The last 20% was just like I've never touched, but I have a approximation and a good idea of how it's being written and what's going on. There's a saying that I'd rather be approximately right than precisely wrong. And so, so why am I rambling like this, right? I'm kind of going. What I'm saying is that you're always going to be dealing with imperfect information. The question is how quickly you can recover from it. And as long as you're working on that, you're training the right muscles. After that is just like what people will give you is like, here's how to think about the engineering problem. That's what I think is the real value at Fang companies. It's not necessarily like, oh, are they going to give me more support for this one project? Because believe it or not, everyone has like, has priorities, and not everybody knows what's going on, because, there's always turnover. You're going to have people leave teams, so some tribal knowledge gets lost and you have to rediscover it. That's always going to be there. What's really important is that you really train that muscle on being able to find out what you're missing and what you're not, and how you can deliver projects and these products faster. So it's like if someone has like these considerations or these thoughts of, oh yeah, like let's say you deliver a project one certain way, right? And you say you come with this implementation, blah blah blah. But then you kind of realize, hey, wait a minute, how would this other guy do it? right? And this is actually a problem that I ran into. Is like, hey, wait a minute, this feels like it took a little bit too long. How would someone else be able to help me? So then maybe like over lunch, take one of those top guys and just say, hey, here's the problem I ran into. Here's all the considerations. Here's the steps that I went through. Is there anything I'm missing here? And they'll tell you yes or no. I think that's really the best way to milk a situation. And I'm kind of curious, like, what steps do you take to figure out if you could do things faster, better, or whatnot?
Yeah. For that, I largely schedule like one-on-ones with people, and I ask for feedback from them.
Uh-huh.
And I'd say I particularly that no one likes to give bad, like negative feedback. Like people are just scared of it. So I really try to press them to say like, what can I improve on, or what didn't go well with this, or like try to steer the conversation towards things that can change and be improved rather than just gold stars for everybody. And yeah, I'd say that's the primary way. And then I think the other thing is I try to ask. I've been getting into this habit more lately, but really focusing on like upfront design first, and then asking for feedback on that design before implementing anything. And I found that actually prevents wasting a bunch of time. Probably the single biggest thing that prevents wasting time, even if it's hard to resist, because like you think you have the idea, like you think you have the solution, and you just want to run with it, and so you can get it done. But I found that like asking for feedback before you start implementing is probably also super helpful, because once you have the design settled, and like once more senior people agree with that, then executing is like really simple. There's no unknowns anymore. You've like eliminated all of the unknowns.
Yeah.
And so you can just run with it. And if you hit a roadblock, then you have other people who understand like why you're doing what you're doing. And so they're just like going to help you figure out how to get past that roadblock, because they already know what's going on and they already have agreed to this design. So they're not going to like, you're not going to have any friction when you hit that roadblock.
Yeah, that's basically what an ERD is really. It's just a formalized process for that, and that's what most big tech companies do. Is literally like, hey, what's your plan for doing this? Submit it, and then ask people. Hello?
What was that?
So that's pretty much what ERD is, engineering review document at big companies. It's literally just planning that, and then asking for feedback, and then everyone will submit their feedback and comments and stuff. Except it's just a more formalized document specifically made for that. But you're basically doing exactly the same thing. Let me guess. Someone up high told you, hey, a way to improve is literally to plan it out first.
Yeah, it's just a common theme that I'd say my team has reinforced, that like planning is not wasting time. We're pretty regularly told that, and that it's better to plan more up front. I guess the collaboration part just comes naturally with that, and we have like a system to produce documents of like different levels of involvement or like effort to create. So we have like short, quick documents that we share, and then we also have like bigger, longer ERD type documents. So yeah, I'd say there's just kind of a pretty good culture around that right now.
Okay.
At least in my team. Yeah.
That's pretty good actually. It's a lot better than I was expecting, because like sometimes everyone just does it by the seat of their pants. But the fact that you actually have some like level of collaboration that people can fill in the answer for you, that's perfectly normal actually. And so to me, the more I hear, the more it's like I'm like saying there's still plenty for you to learn, and as long as you're asking yourself, okay, how can I do this faster and better next time? Not in terms of like knowing stuff, but like in terms of my ability to evaluate the problem. You're pretty much doing the right thing. And so I guess like with that, I'm pretty certain I can give you like kind of an answer. Is that I don't think you're gonna learn any more at FANG than you are like right now, especially if the people who you're working with have experience at FANG, because they're pretty much doing exactly what FANG engineers do. They just like literally plan it out, think about the problem ahead of time, and get some feedback. And then like say, and then the key thing is like, okay, well, next time it's not just like knowing that this fact exists, it's knowing how do I discover this fact the next time myself. And that's really the key difference. It's like literally just taking that whole process of like, oh yeah, I am literally just going to try think about this problem. I have this checklist, and then always improving that checklist and that flow of thinking. And as long as that's continually changing and getting better, and that you're able to land more and more impactful projects, then that's pretty much fine. I don't see like what Fang is necessarily going to give you. The only difference is like, well, you might get more experienced people, but I would imagine that as long as you're getting like some level of feedback from people who are like even like with 4 or 5 years of experience than you, and your leads are like somewhat involved in what you're doing, then I think it's actually completely okay.
Okay. Yeah, that's good context to have.
I was gonna say like the one time the what's it called the reason I would leave is if my thinking's not changing, and it's like I have no feedback. I have no one knows like how to change it. Like so, for instance, that's actually kind of one of the reasons I left Apple was because some of the work I wanted to do was completely architectural, and all my life I've been written like product, right? And so I'm like, how do I think about these things? What exactly is going on here? Like, how should I think about refactoring our architecture? Did I do this even right? And there was no one to tell me, and the only thing I could do was really wait for 2-3 years, wait for the architecture to bite me in the ass if it really was right or wrong. And I just didn't know. I had no feedback, you know? And that's the part, that's the moment I knew it was like time to go. But as long as you're getting that feedback, and and that thinking is improving, and you feel like you're getting good answers from it, and you feel like you're getting better at evaluating these problems day by day, step by step, then I think there's still always plenty to learn.
Yeah. I'd say the only piece of this this that we haven't touched on yet is that because it's so execution driven, sometimes I'm not working on things that I think are actually going to grow my skill set or career in a way that I think is beneficial. I think I imagine this happens at every company to some degree, so I don't know if Fang would necessarily be that different. But it is something that, like, I've noticed that I don't necessarily have I have a lot of ownership over things that I do, but I don't necessarily have a lot of ownership over deciding what I'm going to do. Because, like, and this is true for everyone, like, everyone is just pushing towards these goals. And it's less about, like, your personal goals and desires and more about the company's, which, yeah, I don't know if that's any less true at a Fang company, though. So
it's not really as true. I mean, definitely there are some companies, like, say, for instance, like Google, that will give you like 20% chance or 20% of your time to do things that you feel are meaningful, and that 8% chances, 8% of the time is geared towards what the manager wants you to do. But really, this doesn't really change because, you know, every single organization and every single team has made promises to leadership, and they said, hey, we're gonna do this by this quarter, and so fundamentally that's not gonna change. Like there's always like a manager that's planning out, hey, we need to accomplish these 10 things, you know, and those 10 things might not be anything you want to do, you know, and so sometimes you just gotta like live with that and you gotta deal with it, right? But the most important thing is, as long as you're thinking about these problems correctly and you can keep evaluating future problems with the same framework, just faster and better, then you're on the right path. Let me tell you, I'll give you an example. So in my own career, like, when I was at Apple, I would always think about, okay, why is this the best solution? What are the alternatives? And, you know, like, what, and does everyone agree? You know, like, that's a pretty basic one. I think that anyone at L3, L4 is capable of doing. But then when I started getting to more architecture type of work, I realized that this was like and I realized that, like, after this I was making like some pretty bad mistakes. Like, wait, I'm you know, screwing up some tests. Like, why this is very uncharacteristic. I have testing in my my checklist. Why did I still like miss out on the test? And then I realized that one of the things was that I need to set the end state, the end goal for myself, and for the what's called for the project, because, you know, it's one thing to say, hey, design this app to make it look like this, right? Or this feature to do this, XYZ. And that's all very much set for you, right? But when it comes to something as nebulous as how do we migrate our entire code base from one build system to another, that's not well defined, right? Like, we already know what, like, the end state is. Like, yeah, we wanted to build with this new build system, but how do we do that? You know, it's not clear. And that's the part where you need to set the, what's called, the goal for. But the overall architecture is the overall framework that you need to ask yourself is still exactly the same. It's like, why is this the best solution? Why is this the best way to go about doing this compared to anything else? It's just that I'm not dealing with code anymore. I'm not dealing with refactored architecture. I'm not dealing with legacy code base or anything like that. I'm just dealing with a process, and a process of essentially refactoring on a macro level rather than just refactoring and writing new code. Because for product, once you've written a product once, then chances are like most screens are going to be very similar. And once you've gotten that one home run, you can get a bunch of other home runs as well just by copy pasting that exact formula and then just kind of like tweaking one or two variables. And that's the mark of like an L4, L5-ish engineer, when you can not only do that, but then also lead a team. But then beyond that, and I think this is kind of like where you want to go with your career, is that it's up to you to really set those standards, goals, and where you want the project to head. And that's like, and you can only really do that if you are capable of evaluating code, engineering, and all that jazz in the right way. And it just kind of starts with being able to do that at the L3 level with code. So I think what the point I'm trying to make with all this is that I think you have this misconception of like, oh, it's just about who knows more. And like, oh, if I study like Kubernetes, if I study deployment systems, if I study Jenkins and all that stuff, and all these 10,000 other systems, and like know how they work perfectly inside and out, then I will become a really great engineer. But it turns out that's actually not really the case, because no one understands how these systems perfectly work. They have an approximately good idea of how it works and have written stuff for it before and have an approximately good idea of like what will happen simply by sheer experience. But these things change all the time, right? And so you're going to have to learn like new technologies, new things that have been rewritten. And so at best, you can only get up to 80%. And this is like with a somewhat static code base. Of course, with big tech companies, you're going to have more areas that are going to be refactored, that are going to be changing. And so it's not, again, like I said, it's not about who knows more necessarily, although that's certainly true to a very large extent. It's also about your ability to process that new information and learn what you've missed out on, what you don't, and how to properly evaluate these engineering projects. And as long as you're like getting faster and better at it with better accuracy, without like causing regressions, without like missing edge cases, and delivering things like without losing accuracy, you're pretty much on the right path. So for me, as long as you're getting that kind of feedback and you're getting better at it, there's no reason to leave.
Okay.
I know that was kind of long-winded, but hopefully that kind of made sense. That's at least my opinion.
Yeah, it does. It definitely does.
Yeah. And tell me if I'm wrong about like that impression I had of like, oh yeah, it's about whoever knows more. I get the feeling that's kind of like what you were expecting.
Yeah, maybe not who knows more, but who has. I guess it's almost like if you want to be the best at something, that should be your day in and day out. And I guess my concern is that because this startup is so execution focused, that I might be missing out on a lot of opportunity to focus on like the skills and craft that I actually want to focus on.
Mm-hmm.
And that FANG might be a better place to focus on those things, because you don't have to deal with all these like extra tasks. But at the same time, based on what you're saying, those extra tasks are also like opportunities to get better at that loop.
Mm-hmm.
So like it's like a new problem, new domain, so you have to think about like, how can I learn this as quickly as possible, or like, what do I need to know to be able to do this task, and like getting better and faster at that. I can see how there's more opportunity if you're not as focused on one specific domain or like skill set.
Oh, no, you should still do that with one specific domain, because you'll get faster and better just simply focusing on one thing, right? It doesn't make sense if you just keep switching around, although that's something you should be able to do. Like, I need to work on this one screen or one tech stack, and then the next one, right? But what I'm saying is that, how do I describe this? Is that you need to be, it's not just like being pigeonholed here, right? Because eventually, like I said, things change. You might want to go to a different team, and then you might have to start all over again. And so if you take the approach that, it's all about how much knowledge I have, and then it's like once the moment the environment changes, you're gonna start from zero again, and you'll go all the way back to L3. And I've seen this happen quite a bit, where builders get like kind of stuck at like, I only know this one tech stack, and that's why I'm at an L5, and I've survived everyone else who has left. So I'm the guy who knows more, but then that's the person who also can't. But if someone else shows up with that better instinct and muscle of like how to evaluate problems, they're gonna beat that person in less than a year. I guarantee you. This is why, like, if you take someone who's a staff engineer at like Google, or maybe not Google, but let's say like Amazon, and you put them in Facebook, you might think at first, oh yeah, the L5 is going to be better than the L6 because than the L6 transplant because the L6 engineer is like he hasn't had a chance to learn all these different tools and different like code bases and stuff, right? But it turns out like within 6 months, the L6 engineer is going to run circles just because like he knows how to think about these things much better and plan and execute on tasks so much better than anyone else. And that's kind of like why leveling across the industry is actually pretty good, because it turns out like doing similar shit at like say Amazon prepares you to have the right thoughts and the right the right execution muscles at like say Facebook.
Mm.
I mean,
Yeah, that makes sense.
Yeah, and like you said, you're very early on in your career. It doesn't actually matter that much, like which company you kind of end up at. What really matters is that execution. So as long as you're training it, you're fine. I know I'm kind of sound like a broken record here, but like believe me, in 3-4 years, you will see a very significant difference between you and anyone else.
Okay. Yeah, that makes sense.
Of course, I know other people have
really
different opinions, so I mean, it just kind of depends on what you're looking for, I guess.
Yeah, and I the other thing, what are your thoughts on like the Fang mystique? Like, it sounds like that's kind of not really very real. But I guess like, how do you think it changes someone's future career opportunities or future trajectory versus some other Bay Area tech company?
I think the mystique is real. It's like all other things being equal, the Fang mystique is real, actually. That's not to say that I haven't seen teams and people who act like fucking monkeys and just like don't know what the fuck they're doing and they become like code monkeys, right? I'm not saying that. I'm saying that by and large, it's going to be in favor of competent engineers because, simply put, it's that because of the scale you're working on, the small little things just end up becoming very, very significant, right? And because of that, you need to have an appreciation and eye for detail and be able to think in a way that allows you to scale that system further and further out. So let me give you an example. So it's like, for instance, anyone can build a sandcastle, right? But then when you want to start building things like skyscrapers, then it's like, well, you have a few things between that. Yeah, you have a sandcastle, then you have a house, then you have apartment complex, then you have a skyscraper, right? So you're not gonna necessarily hire some guy who builds like fucking sandcastles all day to build the fucking World Trade Center, right? And so, but because like there's so many more other factors that go into it, right? Just the height of it, the tensile strength of like the beams, and all that other stuff, right? And so it's being able to understand and identify like all that other things that actually are important. And so that's why the mystique is there. It's because everything needs to be structured and organized, and you don't get away with being disorganized and just kind of doing things willy nilly. That's why I think the Fang mystique is there, and it's real. The problem with like why people can and say like, oh yeah, Fang mystique is not real, etc. I know some guy who had Google is an idiot. It's like yeah. To some extent, we do need some engineers who are just willing to do the grunt work. A team can't be composed of stars, right? Like you got Michael Jordan, Scottie Pippen, and Dennis Rodman. Everyone else, like is gonna be like accessories to them. You can't have a entire team full of Michael Jordans, and that's just not possible. It's not gonna work like that. And so that's kind of like why there is that that little pushback, and I agree it does exist to an extent. But like as long as the person at the Fang company is like stays there for a long time, chances are he's like very important and he knows how to think about these things right. And if he does do that, he's gonna be a better engineer than say run-of-the-mill engineer who just like doesn't care and just like has been building sandcastles all day. Does that kind of make sense?
Yeah. The scale and the margin for error and attention to detail makes a lot of sense.
Exactly. That's really what you're looking at. And that's the power of the Fang engineer, I would say. As long, of course, like I said, some people are just building sandcastles all day, and it's on a case by case basis. But like all things being equal, I would definitely take the Fang engineer.
Okay.
Yeah. But that's not to say like there aren't opportunities or ways of getting the same exact experience in your current company. I mean, again, I don't know your situation, but I kind of figure that as long as you're working with people who you really respect and you're learning from, there's not much else you really need. Because I'll tell you this, it's fucking hell working for people you absolutely fucking hate and don't care about and don't like. Yeah, because
I'm definitely not in that position right now, which is good.
Yeah, I'll tell you, like I think I've like tasted this before in my life. I'm telling you, I will never do that again. You cannot pay me enough to want to make me kill myself every single day. Like, a great way and this is like a message to like any managers or someone who is in the chat is like a great way to lose a really good employee is to reward bad ones. Like it's like a really good employee who like really fucking tries hard, knows his shit, and is like doing really well. The manager thinks, oh yeah, he's not someone I have to worry about. I just need to worry about the guys who don't care and like just get them incentives to really participate and play along, right? But then we're social creatures. So then the guy who is like caring and really really putting all his effort in, he sees the manager rewarding and paying attention to all the fucking bad people, right? And so he's like thinking, what the fuck? Why am I not getting this? Like I want the attention, I want the reward, I want the recognition. But you're rewarding people who don't care and don't give a shit. Why should I try? You're not recognizing me. I'm not gonna fucking do shit for you. So that's a really bad situation to be in, and I've seen that a lot. And I've been in that situation a lot. And I'll tell you this: no amount of money is ever worth feeling like that. It's a really miserable way to live.
Yeah. I will avoid that. I've had a slightly similar experience in my past where my peers were all great, but the manager was not.
Oh, that's better. Yeah, that's a little better than mine. Like, that my peers were like, "Oh my fucking god," and the manager was like, "Oh my fucking god." Yeah. And that's literally the worst thing. So, like, even though you might think about being transferred to Fang, it's just like you have no guarantee on the team that you join.
Yeah.
So, that's everything I got.
Yeah, and I mean, Fang's always there too, which is something I've always told myself. Like, you don't have to go at any point. Like, you can go later. And I think with I don't know. I guess I feel somewhat confident that I'll be able to have a solid chance at joining Fang later, given my previous experience. With it. So
yeah, and I think I kind of consulted with you a little bit about your results, and I do remember that you at least got like quite a few offers before in the past.
Yeah.
Pretty consistently, yeah. So it's like if you can do that once, and as long as you're like kind of doing like what I suggest for like approaching the problem, you'll get it again.
Yeah. And so like timing matters less.
Yeah.
In that regard.
Yeah, as long as you're learning and focusing on the right things, when the opportunity comes, it'll be blindingly obvious. Like as long as it like aligns with what you're trying to do and what you're trying to accomplish, the move will be so obvious to you that you don't need anyone else to tell you, or you don't need to like even consult me for it. It'll be like, I know you said that you want to learn. Well, you'll know when you're not learning, when you're not improving, when it's like it just doesn't make sense anymore. I just feel like you're chewing dried chicken, doing nothing significant. That day will be immediately obvious to you, and you'll know what to do.
Yeah, I definitely don't feel that currently.
Yeah, but believe me, you focus on the right thing, you're doing the right thing.
Okay, cool. Yeah, well, this is super helpful. I don't really have anything. I think, that was my main. I think we hit everything on my list.
All right, sounds good, man. I'll let you go then.
Yeah, but thank you. Thank you for taking the time and for everyone listening. I hope this is helpful and applicable to your situation. I'd say just listen to Edward's advice about how to prepare for these interviews.
Yeah, pretty soon I'll also be a career coach too.
Oh, nice.
Maybe. I don't know. I'm just doing this for fun, so.
Yeah. Well, I appreciate it, and different perspectives are always helpful. So thank you. And that's all I have.
All right, yeah, good talking to you, and do stay in touch.
All right, likewise. Yeah.
All right, take care. Bye-bye.
Bye.
Okay. Cool. So that was it. Any other questions from the crowd? Let's see what. I didn't get a chance to really answer very many questions, so let's scroll up. Microsoft Word, yeah. I think it's more fun foundational understanding of DP as an algorithm method. Yes. Answer to everything is beer. Yes. Alcohol is great, man. I'm not an alcoholic, but like, boy, do I wish I was. I'm just kidding. Don't do it. Don't do that shit, man. But yeah, I do need a beer after like I'm like stressed out just like thinking about his situation. Do you not pass Facebook? When in the stream did he mention that? Oh, it's like in private. We kind of looked over the results, and he basically didn't do well on the online assessment. It was a little bit suboptimal, like just a cut under average. And then he did okay on the phone screen, except he needed a little bit of a hint. So, and he just kind of like missed some very obvious things that we've kind of mentioned in the past, like no magic bullet, be a little bit more flexible in your thinking. But again, this all boils down to having a good instinct. And that's something that's going to come with time, as long as he does this the right way. So that's what I mean by, like, I'm really hoping the instinct comes. And as long as he's, like, practicing the right thing, he'll see that pattern, and if he sees that pattern, then he'll know how to react properly. So that's kind of like what I'm focusing on. I would have answering questions drunk is awesome. Yeah. I mean, I don't think I've ever done a drunk stream before. I played Dota drunk, and that's not great. I've really sucked ass at that. Do I only coach new grads? No, I coach anyone as long as I think they're hardworking. In fact, this is the first time I'm coaching a purely new grad for like a long term. I've been always very hesitant to do coach new grads because one, I do know that they need the money out of college, and my fee is very expensive. But I made an exception for this guy, for M, because he said that he's okay with it, and he's financially okay because he works while going to school, and that he can afford it. So like, okay, fine. As long as you're not like stressing yourself out and stretching it to make this happen, then okay, that's fine. But yeah, and it's also like part of it is that I find that for most new guys, they kind of a lot of what I say kind of goes over the head just because they don't have like the same life or professional experience to really understand the gravity. You know, there's like what I say and then the meaning behind it. There's always going to be like double or triple meaning, and there's going to be a lot more to it than what I'm saying. Just because like, you know, that's kind of like how language works, right? It's just like there's almost always like more to the words other than the literal words themselves. So that's kind of like why I kind of avoid new grads, and I made an exception here. I just want to see if I could do it. I think he has a form and meta streaming. I don't know what that means. Streaming is interesting. I used Edward's video to help me land my current dev job with other resources, so it's kind of cool seeing it in real time. Yeah. I mean, I did that with R. In case you missed it, we had one other client here, Russell. He actually like straight up got like a $250,000 Google offer. And he did it. He got 100% hit rate, like pass rate on all his interviews while having COVID. So I don't know. If you're still complaining about coding interviews, I want you to like complain that I want you to explain how someone with COVID can pass 100% of his interviews. That's all you gotta do, man. So I don't buy the fucking whole story of like, oh yeah, it's all luck. Like fuck you, it's not luck. Which means you could have get into technical debt eventually if you're working outside of work. Yeah. Thank for branding. Yes. One thing about startups is that might not be around in a few years. Yeah, but like I said, as long as you're like learning how to evaluate these things faster and be a better engineer, you're always going to have opportunities available to you. So the key is literally to stay in the game as long as possible. You know, it's not about like cashing out your chips on the first job you have, because it's like at the end of the day, it's peanuts compared to what you can be earning over like 15 years. Like you have an 8-year career in the NBA versus a 15-year career in the NBA, you're gonna get like your paycheck's gonna rise over time, right? Like imagine if Kobe only played for like if Michael Jordan only played for like the first 8 years of his career, he would only have one fucking ring. There's a reason, you know. It's like being able to consistently deliver results over a very long period of time, you know, and that's how you get 6 rings instead of 1. That's it. It's a very simple game because you know technology changes, things get updated, and there's like new ways of doing things. But what's really important is that you're constantly learning how to learn and all these different how to deal with all these different situations. Once you do that, then the answer becomes very simple, and you'll stay in the game for very long. You'll stay in the game for a long time. You won't have to like pivot to becoming a manager and telling other people what to do. Programming, stupid bullying, blah blah blah. And that's a way to ask effective questions. Correct. Yeah. Same about head out. How do you best develop the instinct, and just how much EPI and grokking do you think people need on average? If you're talking about the instinct for like coding, in general, it's just done through practical experience. Like, do a project, get some feedback on it on how to do it faster and better. Ask someone better than you how they would have approached the project, or if they have criticism of like what you screwed up on, ask yourself how to avoid that screw up in the future and change your approach. And eventually, over time, you'll grow it. I think my video on how to deliver projects is a very basic framework. Of course, there's like plenty of other nuanced questions in there that I'll ask myself. But in general, if you follow that video, you can pretty much deliver at an L5 level. Actually, I would say, as long as you like follow it to a T. Of course, there's always like some other small little instincts and things in there that will mess you up, and those come with experience. But in general, that framework I think is pretty good. So if you want, I'll link it in the chat. Actually, hold up. Yeah, how to manage and submit software engineering projects. I think that's going to be the video. So let me link it to you guys. I mean, it would vary depend based on your right. Grokking is sexy. One thing Ever said was not to overlook at the solution. You have to figure out the optimal way and watch streams to think about it. Yeah, I mean, you can watch my stream. The stream is literally just there to say, hey, hey, this guy, you can watch in real time his mistakes, what I do to help him correct it, and then you can always think to yourself, hey, yeah, I'm making the exact same mistake. How do I correct it? So just do what Edward recommended this guy to do. And there's like 1,000 different ways to make mistakes, man. The question is, do I talk about the right one for you? And if nothing else, you at least get to see, hey, wait a minute, I could possibly make this mistake in the future. And that's really what this is. It's like your ability to see if you are going to make these mistakes. And if you do, it's like, hey, wait a minute, Edward's talked about this before. I know how to deal with this. I know what practice I need to do in order to get over these mistakes and fix them. You know, that's kind of what the stream is here for. Like, if you're actively thinking about like how to improve, this stream is going to be very, very useful. If you're just doing it for entertainment, I don't know how entertaining this is going to be for like people. I mean, hopefully it's somewhat entertaining. I mean, you know, but like more so, I'm really hoping that like the people who out there who are taking this seriously, like just watch it and just kind of like say, hey, yeah, this is basically free coaching, because it pretty much is really. There's not too like there's only a finite number of solutions that I have, but there's 1,000 mistakes that you could make. So it's really about matching up. Okay, which one of my solutions that I'm giving you? I would say probably like I have like 15 different solutions to things in terms of like correcting mistakes, and just like which one applies to you. That's it. And so yeah, since I see that I'm not really getting any other questions, I guess I'll stop the stream here today. Thank you all for joining me. Hope you guys enjoyed that. Hope you guys learned something, and hope you enjoyed the special guest. I guess he wanted to be anonymous, which is perfectly fine, but hopefully you guys got something out of it too. So we will have a stream on Saturday, and you know, we will see what happens. And yeah, well, Saturday 11 a.m. Pacific Standard Time. Thank you all for joining me. You can contact me on my socials. Socials are in the description. If you want to be coached, you can book me for coaching at echantech.com. Otherwise, thank you all for watching, and I'll see you next time.